Genomic selection is a concept based on using information from DNA to collect a direct genomic value of an animal. The genomic values of the animal is then associated with quantitative traits such as milk production and fertility so that it can be incorporated into the breeding value of the animal. From here, breeders can then calculate what is referred to as the genomic enhanced breeding value based on performance of data records from the farm as well as DNA information from the individual animal.
With genomic selection, it is possible to predict at a very young age whether a bull will transmit the qualities desired by different markets. Breeding organizations can use sires of the sons at a younger age because by using genomic selection, we can determine much more quickly which bulls will be the most successful out of the bunch. This can lead to the ability of reducing the generation intervals than previously, which then leads to eliminating the cost of progeny testing.
Genetic breeding companies use genomic selection because it helps speed up genetic gains for their programs. The goal of genomic selection is to capture specific allelic variations across an entire genome that can be associated with the phenotypic traits within a population.
Currently, dairy cattle are being used over beef cattle for genomic selection due to the fact that there is a high genetic linkage that exists from the widespread use of global artificial insemination sires by virtually all dairy countries of the world. Dairy cattle also have quantitative traits that correlate to production and health within the dairy cattle. Afterwards, a farmer or breeder can get small gains in their herd by utilizing these markers. This lets them improve rates of genetic gain while also lowering the cost of their breeding programs. Notably, most dairy cattle traits have many genes of small effect and few or none to moderate to large effect.